Good evening, ma'am.
Hello, students.
Good evening, ma'am.
Mm,
Good evening, ma'am.
How are you guys? Please put your camera on. Riyan, Tanurag.
Ma'am,
Mm-hmm.
actually, I did not join the last class, so can you revise it?
Yeah, sure.
Come.
So in the last class, we discussed about the charges only, right? So how they are getting transferred, about the static electric charge. So whenever you rub any two objects, so charges are generated, right? Shivram?
Yes, ma'am.
So those charges, they cannot move. So those are called as static charges.
Okay,
Understand?
ma'am.
Okay, so whenever you're whenever those charged objects are like when they are coming in contact continuously, then further transfer of electrons takes place. Okay, so thus transfer of electron, that is movement of electron, leads to the generation of electric current. So what is electric current? Electric current is the transfer
The flow
of,
of charges.
yeah, flow of charges or movement of the charges is considered as current electricity. Okay, thus current is formed. Understand?
Yes,
So
ma'am.
now we see how these transfer of charges is happening. Transfer of charges. So charges generally transfer from one object to another object. So by two methods. The first method is conduction method. What is the first method? Conduction method. So in this conduction method, here whenever the charged object comes in contact with a conductor. So what is a conductor? Conductor is such an object or such a substance which can allow the charges to flow in it. Okay. So because of that, it results in the transfer of charges through the conductor. Okay.
Ma'am, so there is production of current?
Yes.
Okay.
Whenever Charges transfer, so it leads to the production of current. Okay. So what is conduction? Transfer of charges through the conductor. So the transfer of charges through the conductor is called as conduction. Understand? So let's see. Now we are taking a metal here. So what we are taking? A metal. So metal is having no charges. Okay, neutral metal. So there is no charge on this metal, neutral metal. So to this metal, if I am taking any other object which is having charge on it. So I am taking a plate of aluminum, so which is having charges on it. So this is aluminum plate. Aluminum plate. Okay, whenever this aluminum plate comes in contact with this neutral metal, so the charge transfer takes place. Okay, so what is this having, students? Plus charge. It means if this aluminum plate is having plus charge, it means it is, what about the electrons? Electrons are low or high in this aluminum plate?
Low.
Very
Low.
good. Yes, electrons are low. So electrons are nothing but negative charge. So plus charge indicates there are more plus charges, less electron. So transfer of electron takes place from this neutral metal to the aluminum plate. Understand? So electrons are excess in this one. So when the positively charged aluminum plate is touched to the metal sphere, so electrons are drawn off the sphere onto the aluminum plate. Okay, so that leads to the, so as this is giving its electrons to the aluminum plate, the number of plus charges on the aluminum decreases, right? Because those are neutralized by the negative charge. And on the metal, you can see positive charges are generated, right? Why, students? Why? Because electrons have gone
Because
outside.
it loses the electrons.
Yeah, electrons have gone outside. It is having plus charges which are in excess now compared to the electrons. So now you can see that on aluminum, less excess positive charge, and on metal surface also has excess of positive charge. Understand?
Yes,
So
ma'am.
this is the conduction. So here you can see that flow of electron is taking place. Clear with this, Rohini? Every time you will be asking like, what happens if a charged species come in contact with neutral species? This is what happened. So whatever requirement is there, here electrons are less. So wherever the electrons are more, those are getting transferred to the less number side. So because of that, you can see in both the substance, charges are generated.
Okay, ma'am.
Okay.
So,
Yes.
ma'am, like in power plants like hydroelectricity and all, electricity is created. So it means electrons are created, right? So how they are created?
See, electricity generation is through the electrolysis process where water is used. So they use the water and they convert. So they will break that water molecule, because of that electrons are liberated out.
Okay,
So
ma'am.
charges are generated. So whenever water molecule breaks, it gives rise to 2H plus ions plus OH minus ions. Okay. So water leads to the generation of charges. Whenever electrolysis happen, a generation of charges takes place. That leads to the production of electricity.
Okay, ma'am.
Ma'am, so in place of this positive Ma'am, if there is less negative means it is positively charged, right?
Yeah.
Yeah, so in place of this positively charged, if there is negative charge also, the same thing is gonna happen.
Yeah, here there is negative charge, right? So this object is like already neutral. It doesn't need electron.
Oh, so it doesn't attract.
Yeah, maybe it may transfer, but not much.
Okay.
Ma'am, will the aluminum plate become neutral?
No, like it decrease some of its positive electron, some of its deficiency. So if it is at whatever the need requirement is there, if it takes everything, then it becomes neutral.
And so it can become neutral.
Yeah.
So there is a chance of it becoming neutral, right? Then
Yes.
this
Yes.
will be charged. So then
Yes.
the other one will be charged.
Yes.
Okay.
Understand?
Are magnets conductors of electricity?
Yeah, I do connect. Next one, induction. What does induction mean? So whenever any object, like whenever you can write the definition, then I'll draw the diagram. Based on that, we can try to understand what is induction. So induction is when a charged object is brought near the neutral object, it results in shifting the position of electrons in that object. Okay, based on the requirement. Okay, see, you can write that when a charged object is brought near a neutral object, it results in shifting of the position, shifting in the position of the electron, shifting in the position of the electron in the other object. So here, let's see what is happening. So first we take a metal, which is a neutral object. To this metal, you are taking an object which is having charge. Okay. So now this metal, whatever you are taking, this metal, because of the generation of the charges in this metal, now this metal is neutral, right? Neutral in the sense it is having equal number of positive charges and negative charges, right? So let's say it has 4 positive charges, 3 positive charges and 3 negative charges. So these are aligned in such a way that this positive is attracted towards negative, like the position, there is shift in the position. Understand? So as you are taking the negatively charged object towards this neutral metal, so positively charged charges are attracted towards the side of the metal. Thus, you can see electrons are pulled to the other side. Okay. Understand?
Ma'am, can you repeat?
See here, what you are doing, you are taking a charged object to the neutral object. So what is neutral means, students? Neutral in the sense, it doesn't mean that it is not having any charges. It has. So neutral in the sense, when it can become neutral, if the number of positive charges are equal to number of negative charges, like +5 and -5 are equal, so then its charge is going to be 0. So it doesn't show any charge on it. Understand? So I'm considering like it has 3 positive charges and 3 negative charges. It's a neutral one. Okay. So as you're taking negatively charged object towards this metal, so this negatively charged attracts which one? The positively charged particles towards itself. So you can see that positively charge is pulled to one side and electrons are pulled to the other side. Understand?
Yes,
ma'am.
So here, what you can write one more definition for induction for better understanding. You can write this. So it is nothing but you are charging an object. Okay. You are generating charges on an object. How you are generating? You are not touching it directly, but with a charged object, you are making a neutral object to generate charges. That is called as induction. Okay. Means charging an object without touching it directly. Without touching it directly. But what you are doing with a charged object. So without touching directly with a charged object, so you are charging an object. So that is called as induction. So you can see here, whenever a charged object is brought towards a neutral object, here in the neutral object, the charges are being separated and the electrons are moved to one side. Okay, as the electrons are moved to one side, when you put hand towards this side. So when you put hand, let's say I'm using my hand. Okay. So when I'm putting my hand, so whatever the negative charges are there, those go out and they reach the earth. So they go into the earth. You're getting? So as the electrons are pushed away to one side, whenever you touch it with your hand, so your hand acts as a pathway for the removal of those negative charge from the object. So this hand acts like a pathway. So the electrons come out through your hand and they reach the ground.
Ma'am,
Mm-hmm.
is this like a magnet?
Which one?
This induction.
No.
Okay.
Okay. You're getting? So when you are using hand, so the electrons, they come out, it acts like a path. Okay, it acts like a path and it goes into the ground. So when you talk about Rian, you are asking me about magnet. In magnet, it can attract the objects. Okay, here there is no attraction. So without touching it, Without touching, it is helping to move the charges. But magnet, to move charges, it needs to touch. Like there should be touch in the magnet. So that's not happening here. It is similar to that phenomenon, but not exactly same one. Okay.
Ma'am,
Okay, ma'am.
ma'am, in conduction also there is touch.
Yeah. In conduction, there is physical contact. Here, there is no physical contact. Here, you are making closer to it. Without
Okay.
touching, you are doing.
Okay. Ma'am,
Okay.
and also one more thing.
Mhm.
Here, a negatively charged object is brought near to this neutral one, so
Hmm.
that these charges are separated to different positions. So
Hmm.
now this means that when this neutral object is brought near to this charged one, this neutral one is no more neutral. So like the charges cannot cancel each other right now.
No, these are like separated. Still, it's a neutral, but the charges inside got separated.
Okay.
So as the charges got separated, when you put hand on it with your hand, these charges, these electrons removed from the object. So you can say that this is your hand acting like a ground wire. Your hand allows excess electron to leave the sphere. So thus sphere loses electron and it become positively charged now. So for the negative charge, what is needed? Positive only. So electrons are not needed. That's what excess electrons are going away. So that's this object is becoming charged. Understand?
If we put the hand on the other side.
How can you put hand on the other side? Here this object is, so nothing happens. Whatever extra is there, only those are going away. Only electron can travel, not the positive charge.
So
Positively charged never travels. Okay. So thus you can see that you can see the object and this metal with the positive charges. So thus this metal is charged now. Okay. So later on, if you remove this, the object, then you can see this positively charges are evenly spread. Okay. These are evenly spread. So consider 4, that would be better. So thus you are making an object charged without touching it, without any physical contact. You are brought simply a charged object and you are making a neutral one, a charged one. Understand? Understand, students?
Yes, ma'am.
Okay. So here you are charging an object, like your object is becoming charged without touching. Okay. So we can write simply the conclusion about the conduction as well as the induction. So in the induction, you cannot see a physical contact between the charged and uncharged object, but in conduction, you need a physical contact between them. So in conduction, a physical contact is needed between a charged and uncharged object, whereas it is not needed in induction. Understand with the two concept students, induction and the conduction.
Ma'am, so after induction, if we bring this neutral object and this negatively charged object in touch, like in physical contact, then the electrons will be moving, and then now there will be conduction of the charges.
See, here there are no more electrons for the conduction. Here the electrons are removed already.
Ma'am, but there are protons. So this negatively charged object, if it is brought in contact with this positively charged one, then
Yeah, then
the
electrons from that negatively charged again enters into this positively charged one.
so now there is flow of electrons. I mean flow of charges.
Flow of electrons takes place. Yeah.
So current can be produced.
Yes.
Okay.
So as it is a metal, metal is a good conductor, current can be produced.
Okay.
Clear, students?
Yes, ma'am.
Okay. So next one about electroscope. What is electroscope? So electroscope is a device which helps to test the presence of charge on an object. Okay. It is a device which can test if an object is charged or not. And this was first proposed by the scientist, like developed by a scientist, Abraham Bennett. So developed by Abraham Bennett. Okay, developed by scientist Abraham Bennett. Understand, students? So let's discuss about the structure of electroscope, how this electroscope look. So done with writing?
Yes, ma'am.
Okay. So next one, structure of an electroscope. Hmm. See, student, this is the structure of electroscope. Okay, so this is a glass jar. Okay, what is this? It is a glass jar. Okay, and this, the one which you can see is the brass rod. What is this one? Brass rod. And these two are your gold foils. Or you can say gold leaves. So these are made up of gold. Okay. This is the cork. So let's discuss about this electroscope. So see, this is the glass jar and we use a brass rod here, which is inserted to the cork, and two gold leaves are used. So why gold is used? Gold is a metal. So you can also use silver. You can also use, mostly gold and silver are used. You can also use copper and aluminum also. Why we are using metals, students? Metals are good conductors. Okay, as metals are good conductors, so we are using the ones which are made up of metals. Okay. So let's write about the structure. So whatever we are taking here. Generally, gold and silver are used to construct an electroscope because why, students, why gold and silver are used? Because, please tell me, because
They're good conductors of
yeah, they
electricity.
are good conductors of electricity because they are good conductors of the electricity. Okay, otherwise you can also use copper and aluminum. Otherwise, copper and aluminum also can be used. Okay, next
Ma'am,
you have it.
I have a doubt.
Hmm.
Ma'am, every object is charged, right? So why only few objects are conductors?
Those are charged, but they should allow the flow of electrons on it, right?
Uh, like, now for example, rubber, it
See,
will
there
attract.
should be movement. There should be movement. Not the generation of charges doesn't give electricity. Whatever the charges produce, those should show movement in it. That's what we mentioned, move of the charges or the flow of charges. Yes, Divesh, you're asking something?
I'm like, what makes an object conduct electricity and does not?
Yeah, mostly metals are good conductors of electricity.
I'm like, why only metals are good? Like, what is in them which makes them a good conductor of
So
electricity?
metals are solids, right? So metals have, like, when you see the structure you study in your higher standard students, when you see the structure you have, like, the free electrons are present in the metal. So because of that, whenever you pass current, those electrons start moving, and the electricity is proceed forward.
Okay,
Understand?
ma'am. Yes, ma'am.
I think in the last class also explained you how solids, how the atoms are arranged, they are compactly arranged. So because of that, move from one atom to another atom, movement is very easy. As well as in metals, you can find a lot of free electrons are present. As though those free, as because of the free electrons, the electricity can pass easily through it. Understand?
Also
See, in
solid.
any object, listen, Rohini, in any object, flow of electricity, like from one end to other end, if the charges are moving, then it is called electricity. Flow of charges from one end to other end. I have explained this definition whenever I gave you about the charges. I told you this. Flow of charges in any object from one end to other end. Understand? Now you're asking something. Tell me, Rohini.
So, ma'am, why only in a few objects only these charges move? Why not in others?
What?
So
That's
why
what I'm
only in a.
telling. Because of the presence of free electrons, it is allowing. Because of the structure, particularly. When you take the metals, in the metals, you can see the atoms are held tightly, and the flow happens very easily in that case.
Okay, ma'am.
Okay. And you can see a brass rod. So brass rod with, on the brass rod, you can see a vertical brass rod is present. Vertical brass rod with gold leaves. How many gold leaves? Like two. Suspended on the one end. And on the other end, you can see like horizontal rod is present. On one end of brass rod, you can see a horizontal rod, and on the other end, you can see gold leaves are suspended. And those are two in number. Okay, clear? Please write down. Last start. Done, students?
Yes, ma'am.
Okay, let's see working of these electroscope. So working. So please draw the diagram, then we can discuss how it works.
Ma'am, in place of the brass rod also, can any other metal be used?
Yeah, no, brass rod is used. Brass is not a metal.
Ma'am, it is an alloy.
Yeah.
Okay.
Which has copper and zinc in it.
Okay.
See what is happening, students. So whenever you brought a charged object towards the electroscope, here we have placed it. So you can see that the negative charges are traveling inside and the gold foil is getting repelled. So this is repulsion. Why repulsion is happening? Because of similar charges. So repulsion is happening. Okay. So that's the working. So whenever a charged object touches the brass disc, the electric charges get transferred from the brass rod, okay, and reach to the gold leaves. So because as the similar charges are getting here, so those are so gold leaves get repelled. Understand? So here it is showing the negative charge. It means the object is said to be negative, negatively charged object. When an charged object touches the brass disc, electric charges get transferred from the brass rod to the gold leaves. As a result, the gold leaves move away from each other, depicting the presence of charges. Understand, students?
Yes, ma'am.
So whenever a charged object is touching this charged electroscope, so this is charged electroscope. Already it has charge, which is negative charge electroscope it is. On this negatively charged electroscope, whenever you are bringing a negatively charged object, so you can see repulsion is happening. Gold foils are moving away. Understand? And always the transfer of electron happen. And I told you the charge is generated only due to the transfer of electrons, not due to the protons. Protons never transfer, only electron transfer. Because of the transfer of electrons only, charges are generated on an object.
Ma'am, what if a positively charged object is kept?
Yeah, then you have to, no, it's still the electron carries.
Ma'am, but positive charges don't move, right?
What don't move?
Like
See,
the
whatever the rod you are taking, that rod should be charged first. Understand? So as this rod is negatively charged, so when you are bringing negative, it is showing repulsion. When you are bringing positive, then no repulsion is seen.
Okay. Ma'am, what if neutral?
How can it be neutral? Still the electrons transfer. See, we only check the presence of the check the presence of charge. So if it is neutral, then it don't show like any kind.
Okay.
Okay. So there would be no moment when you bring any neutral charge object onto this electroscope. Clear, students? Let's discuss what we discussed today in today's class. So we have seen that charges, they transfer, right? So one method we have seen is conduction, the other method is induction. Conduction is such a method where you include a physical contact between the two objects. Here, one you are taking the neutral metal, the other you are taking the aluminum plate, which is of positively charged. So you can see as it is having less number of electrons, the electrons from the neutral metal are getting transferred so that both the charges become the charged one. Both the object becomes a charged one. So in the conduction here, you are making an object charged without touching it. So how you are doing that? You are taking an charged object near to the closer object so that you can see the charges in it are getting separated. When you touch with your hand, so whatever the excess electrons are there, so which are not required now, those are gone uh, to the ground, and then you can see thus a charges are left, that is positively charges are left, and those are finally equally distributed. So this is what induction is. Next one, we have mentioned that in conduction, a physical contact is needed between the charged and uncharged object, whereas in induction, it is not needed. Still, you are making a charged object. So then next, electroscope. Why electroscope is used? To test the presence of charge on any object, electroscope is used. And it was developed by the scientist Abraham Bennett. Okay, so what is the structure of electroscope? We have seen a glass jar and then a cork. Into the cork, you can see a brass rod is inserted. At the bottom of the brass rod, a gold leaf, two gold leaves are used. Okay, so these gold leaves, they show repulsion, they show movement based on the charges. Let's say this brass rod is negatively charged. So onto this negatively charged brass rod, you have bring an object which is negatively charged. So you can see repulsion is happening and the two gold leaves are moving away. Okay, so this is the work of the electroscope. Sorry. Okay. So please tell me if you have any questions before winding the session. Anurag, Rian, Rohini, Divyesh. No questions? So we can end session for today. See you in the next class, guys.
Thank you, ma'am. Bye, ma'am.
Bye.